Hello, my name is Sophie Arbelbide, and I apologize in advance for my camera not being able to flip from showing my face to showing the whiteboard. I feel that I have learned a lot in physical chemistry this semester that will help me in the future and possibly future jobs. I would like to talk about the Clausius-Clapeyron equation. This equation is really cool because it can be used to solve for different variables such as pressure or temperature. And also, in my opinion, I think it's the best equation that we use this semester. So this is a general format right here, or general equation, and it could be rearranged or manipulated in different ways depending on what you're trying to solve for. But the variables will always be the same. So P1 will always be initial pressure, P2 will always be final pressure, delta vaporization H is enthalpy of vaporization in joules per mole. This needs to be joules per mole because the constant 8.3145 joules per mole times Kelvin needs to be the same. T1 is initial temperature and T2 is final temperature, and these are also both in Kelvin. I have a few ways that the equation can be manipulated. So for example, if you're trying to solve for P2, it would look like this. Delta H vaporization would look like this, and T2 would look like this. If you want P1 instead of P2, you would flip these two. And if you want T1 instead of T2, you would flip these two. We learned this first in our vapor pressure module, where I also learned that as temperature goes up, pressure also goes up. This class as a whole will help me, especially next year when I take physics. Not only this module, but the other modules for sure will come in handy. And also learning so many skills in Excel helped me in quantitative analysis lab that I took this semester, and I'm sure will come in handy next semester and later on in my career. Thank you so much for listening.